Assalamu alaikum. In this video we will solve the problem number 728 from the textbook of Behzad Razavi. So the problem said that if lambda don't equal to 0, determine the voltage gain of the stages shown in this figure. So if lambda don't equal to 0, so we will consider the RO of the transistors. So in this video we will not use the T model or P model. Instead we will use the intuitive method or way to get the gain, which this method is very famous. In this type of stages. So the method consists of 3 steps. The first step is we place AC short on the output, and we measure the short current to find the GM. The GM is just the output current over the input voltage. The second step is we short circuit the input and we place a voltage source on the output to find the output resistance or the output impedance, which is R out equal to Vx over Ix in this example. And finally is we just write minus GM that we found times the output impedance. So we will start with the first stage. Just a reminder that the output impedance, because we will need it in this problem. So the diode connected device, the output impedance of diode connected device is just we will draw the P model just to make it very clear. So this RO and this is Vx. So and the drain is connected with the gate. So let's say VGS. Okay. So this is GM VGS. So Ix is just this current plus this current. Okay, so Ix is also VGS is equal to Vx because it is the same from the same potential. Okay, Ix is equal to Vx over RO plus GMVx. So Ix is equal to Vx 1 over RO in parallel with GM. Okay, so Vx, when we flip it, it will become 1 over GM parallel with with RO. Okay, so this is the output impedance of the diode connected device. This is just a reminder. Sorry. So because we need it a lot in this problem. So we will start with the first step, which is finding the GM. Okay, so the GM. So the GM is just the current here is the output current is we just said that we short the output. So the current here is GM Vin. Okay, so the GM is just output current, which is GM Vin over Vin. So it is just GM1. It's just GM1. So the big GM is just GM1 in this stage. Also the output impedance, we will just see the impedance from up and down. So if we look down, the output impedance is RO1 in parallel with. So what's happening? It's happening up is just diode connected device. So it is just as we said 1 over GM 2 in parallel with RO. So this is just 1 over GM 2 parallel with RO. With RO2. Okay. So the voltage gain is just GM1 times minus GM1 times RO1 RO1 in parallel with 1 GM2 parallel with RO2. So this is the voltage gain of the first gain. So this is very intuitive, like when comparing it to T mode or P mode, because it will become very complex, especially when the number of transistors will be high. So the second stage is just the same as the first example. Just there is different. Just the difference is just we have here the a transistor that is biased from a DC voltage. So transistors that based from DC voltage will be considered just as a resistance. Okay, just the arrow of the we just consider the arrow of the arrow of the transistors. Okay, so the GM is the same, which is GM1, same as the previous stage. So R out, if you see down, there is RO1 in parallel with, so this is as we said, so this is like RO2 parallel with 1 over GM3 parallel with arrow, because this is diode connected device. Okay, so RO2 in parallel with 1 over GM3 in parallel with RO3. Okay, so voltage gain is just GM1 minus, I also forget this minus GM1 times RO1 in parallel with RO2 in parallel with 1 over GM3 in parallel with RO3. Okay, let's go for the third stage. So the third stage is the GM is the same, because it's flowing the same transistor. So GM1 and the output impedance is just, if we see up, there is RO, so this is just RO2. So RO2 in parallel with RO1 in parallel is like RO1 in parallel with diode connected device, which is 1 over GM3 parallel with RO3. So RO1 parallel with 1 over GM3 parallel with RO3. So AV is equal to minus GM1 times RO2 parallel with RO1 parallel with 1 over GM3 parallel with RO3. Okay, so the first stage is, so the difference here is like the input voltage is applied to the PMOS, not the NMOS as previously stated. So the GM here is just GM. It's like the previous stages, nothing changes because PMOS is flipped. So the drain is like, it's like this is the RD of the common source of this stage. So GM is just GM2. The R out is from up, it is RO2 in parallel with the same thing. So we will just, to save time, it is just write minus GM2 parallel with RO2 parallel with RO1 parallel with 1 over GM3 parallel with RO3. Stage E. So for stage E, so this is not biased, okay, so we will not consider it, okay, because there's no voltage, so this transistor is off. So This is very simple. So AV is just GM2 minus GM2 times RO2 parallel with RO1. For the stage F, RD may be a bit confusing. So we will do the when we calculate the output impedance, we will draw the P model of this just this stage. So to make it clear, okay. So GM is just GM1. For the out, we will draw the P model as we said. So it is like RD is between the gate and between the gate and drain. So this is GM VGS. So this transistor 2. So this VGS 2. So this VGS 2. Okay, so this is RO. So let's calculate the current flowing through here. So this is Vx, voltage source from here. Okay, so Ix is just the current flowing through here plus the current flowing through RO. So also VGS is equal to Vx from this model. Okay, so from this drawing, I mean, Ix is like GM2 VGS2 plus plus the drop here, the current drop here, Ix, which is Vx minus the voltage drop here, which is Ix RD over RO. So I mean this current. Okay, this current is the voltage here minus this voltage drop over the resistance, which is RO. Okay, RO2, sorry, this transistor. So to make it simple, okay, so this like this over RO2. So this is Vx to make it, to save the time, Vx. So it will become like this: Ix plus RD. Oh, sorry. You save time. 1 plus RD RO2 equal to Vx GM2 plus 1 over RO2. Okay, so Vx over Ix is equal to, so yeah, so 1 over RD. So we will, so RO2 over, so what's it mean? Okay, GM2 over RO2. Okay, so gather it, so it will become RO2 plus RD over 1 plus GM2 RO2. So this is just the output impedance from the PMOS side. So R out is just RO1 in parallel with RO2 plus RD 1 over GM2 RO2 . Okay, so AV is just what we said, that GM is GM1 with RO times minus, sorry, RO1 parallel with RO2 plus RT 1 over 1 GM2 parallel with RO2